Okay, so again with the tangent plane business, right? Just like in G8. So now the specifics are different here. We don't know what this function f is. That's either bad news or good news, depending on how you look at it. The bad news is we don't know the function. The good news is I don't have to write out a bunch of algebra describing what that function is. I can just say f. Right? So that's kind of cool, really. So same deal. I've got some surface. This surface is the graph of f. Said differently, I can define this new function g, whose level set we're looking at, and here's a formula for it. It's just z minus f of x comma y. That's my g function. And so I can find then a normal vector by looking at the gradient of g. And the gradient of g that I'm going to choose to use as my normal vector then is, well, let's see here. It's negative partial of f with respect to x, negative partial of f with respect to y, and then 1. Yeah? Everybody okay? So that's the, oh, sorry. That's the normal vector. Now, okay, so but how does this relate to that equation? Well, I need to write down the equation of this plane. The equation of the plane, as usual, is n dot x equals n dot x naught. I need to know what is this guy. What is that x naught? Well, that x naught is the point in question that I know on the plane, at the point where I want the tangent plane to the surface. And that point, well, we're talking about around the point A, B in the domain, so that means that x is A, y is B, and therefore the z-coordinate is f of AB. So altogether what I have then is this turns into, let me just write it all out. Here's my normal vector. Here's the x vector, x, y, z, equals normal vector dot, and then I've got, let's see here, a, b, f of a, b. All right, so I claim this is the equation of that tangent plane. Is everybody happy with this? Equation of the tangent plane. Came straight out of here. Okay. Right, so okay, well, let's multiply this all out, and there's a bunch of stuff here. Oh, golly, there's a lot of stuff, isn't it? So I've got, x times negative partial of f with respect to x plus y times negative partial of f with respect to y plus z equals, okay, a times negative partial of f with respect to x plus b times negative partial of f with respect to y, and then plus f of ab. And now you got to take this equation. If you toss terms around here and there, claim you can just solve for z, as the hint suggests. The hint says solve for z, and what you get is z equals, well, partial of f with respect to x. Oh, excuse me. You got the f of ab. Let's put that down first. Partial of f with respect to x gets multiplied by both x and a. Other sides, you take this, toss it over to the right-hand side, and what you get is partial of f with respect to x times x minus a. Partial of f with respect to y, same kind of deal. It gets multiplied by both y and b. Again, this goes over the other side. The minus sign goes away. You get times y minus b. Oh, sorry, that wasn't on the... There we go. So let's summarize what we've done. We started by looking at this function. We're looking at the graph of this function. We find the equation for the tangent plane to that graph. And, that's this whole business. But, you got to find the g and normal vectors, etc. Simplify. What we've got here, this is an equation for the tangent plane to the graph of our original function. And I claim, if you think about it, the whole point to a tangent plane is that it stays real close to the original surface. It's like a linear approximation. It's right up on that surface. It's just flat. It just doesn't curve the way the surface does. So the values of z for any point down here in the domain, the value of z on the tangent plane and the value of z on the surface itself, not that different. So the value of z that we just solved for on the tangent plane should be really close to the value of z on the surface itself. So, in other words, the value of f, that is this value of z, should be approximately equal to the point on the tangent plane, namely this value of z. So this is an approximation to f of xy. Or said differently, you could say that this is this new function. We're going to call it the tangent plane approximation. We'll call it p for plane, I guess. P of xy. This is a function that approximates the original function because this is a function that gives you this tangent plane. Does that make sense?
Yeah.
And that's the equation we were supposed to derive for the original, for the statement of the problem. Okay. Is everybody happy with that? Okay, let me stop the recording.